what we will discuss today.
Yes, hello everyone. So today is your week 10 Solve with Us session. Am I audible?
Week 10 doubt solving session, ma'am.
Week 10 Solve with Us session. Doubt session will be on Tuesday.
Okay, fine.
So have you seen the lectures? Have you gone through the topics of week 10? Anyone? Say something yes, no.
No, ma'am.
Okay, so in week 10, we have to study about the expectation and variance of the discrete random variable. So in week 9, you have seen the introduction of random variables, types of random variables. So discrete and continuous, you have studied there. So in week 10, we will study about the expectation, how we calculate the expectation of a random variable and expectation of a function of a random variable, and same things for the variance. Okay. So is my screen visible?
Yes, ma'am.
Okay. So let's take a glimpse of all the topics and then we'll solve some questions. So the very first thing is expectation. So anyone would like to explain about expectation, what it is? So suppose you have a random variable x, okay, which is a discrete random variable here. Okay. So suppose it takes values x1, x2, okay, like this. So the expected value expected value of x is denoted by expectation of x, okay, and is given by, so expectation of random variable x, so it is nothing but the summation over the values of x multiplied by corresponding probabilities. So suppose we have a random variable x which takes some values. So it is taking values, suppose x1, x2, like this. And then it will have some probabilities associated with it. So we have studied about the PMF, right? For a discrete random variable. So what do you
Yes,
mean
ma'am.
by PMF, probability mass function?
Ma'am, it should be greater than 0 and it is equal to 1.
And ma'am, summation of all PMF is equals to 1.
Yeah. So the thing is, it defines the values taken by the random variables and the corresponding probabilities. Okay. So this place will tell the probabilities that the random variable x takes values x1 and this is for x2 and similar to that. Okay. So here for expectation, so this is the value of x and this is the probability that the random variable capital X is taking a particular value small x. And this will go, the summation will be on range of x. So this is the formula for expectation. So what do you mean by expectation is, So expectation is actually the long run average. Okay. So if you do any experiment, so if you perform an experiment a large number of times, okay, so then we say that the average of the outcomes, okay, will be equal to the expected value. Suppose we are rolling a die, okay. So if you roll a die, what is the PMF of it? So in die, it takes values 1 to 6, right? 1, 2, 3, 4, 5, 6. And if you are using a fair die, the probabilities will be 1 by 6 for all the values, right? So you can calculate the expectation, right? And what do we mean by expectation? So if you're rolling a die sufficiently large number of times, so we can say that we get 3.5 outcome. So suppose you are rolling a die 1,000 number of times. So you will get some outcome. Suppose for the first throw you got 1. Then for the second throw, suppose you got 5. Then suppose you got 6. So similarly, you get 1,000 numbers. So if you take average of these 1,000 numbers, 1,000 outcomes, okay, that is equal to the expected value. Okay, so we are not saying that the expected outcome is 3.5. If you calculate, it will come 3.5. So we are not saying that the outcome will be 3.5. What we are saying that the average of the outcomes will be 3.5. So this is how we can define the expectation. Okay, so next is the Bernoulli random variable. So what do you mean by it? Bernoulli random variable? Anyone?
Ma'am, which takes success with probability P and failure as 1 minus P.
Yeah, so Bernoulli random variable is a variable which takes only two values. Okay, so a random variable that takes either value 1 or 0, that is called Bernoulli random variable. So 1 we call it as success and 0 denotes failure. Okay, so I can write.
Can you repeat it, ma'am, again, please?
Yeah, so Bernoulli random variable is a variable which takes only two values, 0 and 1. So 1 represents success here and 0 denotes failure. Okay, so I'm writing it. So a random variable that takes either the value 1 or 0 is called Bernoulli random variable. Okay, so suppose we have a random variable x, okay, which is a Bernoulli random variable. Okay, that takes values. So it is taking value 1 with probability p. Okay, so what will be the PMF of it? So x is taking two values, 0 and 1, and we are saying that the probability that x takes value 1 is p. So what will be the probability for 0?
1 minus P.
1 minus p. So this is the PMF for Bernoulli random variable. It is taking two values only, 0 and 1. Okay, with probabilities. So for 1, the probability is p. For 0, the probability is 1 minus p. Now, if I want to calculate the expected value here, expected value of x, then what it will be?
Ma'am,
Yes.
ma'am, is 0 and 1 represent presence or absence of data?
No, it is not presence or absence. It actually depends on how you define success or failure. So maybe you have one box and which contains some balls. Okay, and you are picking one ball. So these balls are of different colors, and you are saying that if the ball you pick is blue color, then it is a success for us. And if it is a different color, then it is a failure for us. So that depends how we are defining the success and failure. Success and failure are like general terms, and then how we are defining. So that depends on the situation. It may vary from different questions.
Ma'am, can the success and the failure probability be different? Like as you said, in a box there are 5 different color balls. If I pick only blue, it's a success. If I pick some other means, it will become failure. Like that, then my success probability is 1 out of 5, and my failure probability is 4 out of 5. Right? It's a fine.
Yeah, it depends on the number of balls that you have. Okay, so that we
Can
can
the
define.
probability be different? I'm asking, ma'am. Can the probability be different for both
Which both?
success and failure? Probability can be different, right?
Yes, these probability for success and failure, like if for probability for one, which is success, if it is P, then it will be 1 minus P. Because we have only two possibilities, right? And we have the property that the summation over the PMF. Okay, so this should be equal to 1. So if you follow this property, if the probability for 1 is P, then it will be the 1 minus P.
And it is mentioned in the question
Okay, fine,
that
ma'am.
which we will should take as success means
Yeah,
one.
that will be mentioned in the question.
Okay.
Okay, yeah. Otherwise, some
Shouldn't Bernoulli work for only like two outputs, like event which only has two outcomes?
yeah, that's how we define Bernoulli random variable. So here we have two possibilities only.
Then someone just said that we can use Bernoulli theorem with like picking balls and stuff.
See, there is one Bernoulli random variable, Bernoulli distribution, and when we take the summation, so this is like you have this box, right? And you are picking one ball. Okay, so this the ball that you are selecting may be of blue color or maybe different color, and you are saying if the ball is blue, then it is success for us. Okay, so similarly, if you repeat this trial so many number of times, so suppose if you are repeating it n times, then what we do, this Bernoulli random variable x, suppose if it is xi, then we take summation over it. Okay, and the summation of Bernoulli random variables tends to follow binomial. Okay, so suppose you have selected one ball, and now you are defining another variable which is representing number of blue balls. Okay, so suppose you are taking 5 draws, right? So I this n will be 5. You are selecting 5 balls, and for each ball you have two possibilities. Either it will be blue color or it will be a different color, right? So suppose you have drawn 5 balls. Okay, so maybe the number of blue balls could be 0, right? Or maybe 1, or maybe 2, maybe 3, maybe 4 or 5. So this is how it forms
So now this will
binomial
not be
distribution.
a Bernoulli theorem.
This is binomial. So that you will see in the week 11. Summation of Bernoulli random variable becomes binomial. Okay.
Okay, ma'am.
Yeah, I think you are asking about the binomial. Okay, that is binomial, not Bernoulli.
Ma-
Okay,
Ma'am,
that
it is
NCX
same as
formula.
is it same as binary numbers concept?
Binary number, you can say, but that is a different thing. But yeah, you can see in binary also we have two possibilities, 0 and 1. So yeah, you can associate it with that also.
Yes, ma'am.
Excuse me, ma'am. Ma'am, I have some doubts regarding week 9 GA. Can you clear it now or should I wait till the end?
You can check the GA solution PDF.
Ma'am, that's the thing, right? The answer key is wrong.
Which answer? Which
Question
question?
11 and 12.
Is it for everyone? Answer is wrong, or I will check it. What about others? Everyone says that answer is wrong for those questions. Okay, we'll check if it is wrong. Otherwise, you try to solve it once again. Maybe you are mistaking somewhere.
Okay. Ma'am, where is the GA solution PDF?
That will be uploaded on the portal itself. You can check. In the supplementary content, there will be a column GA solution. So there you can
Okay,
find it.
ma'am. Okay.
Okay, so we were talking about the expectation of this Bernoulli. Okay, now look at the formula again. This is how we calculate the expectation. So what we have to do? We have to take this x and then we have to multiply it with the corresponding probabilities. So here you can see this Bernoulli random variable is taking only two values, right? 0 and 1. So the x is, so formula is summation of x into the probability. So first value is taken by x is 0. And what is the probability?
1 minus p.
1 minus p. Okay. Then it is taking second value, which is 1. And the probability is p for it. Now just solve it. So this term will become 0. And this is p. So the expectation for Bernoulli random variable is p. Okay. And this p denotes the probability of success. Okay.
Yes, ma'am. Ma'am, I just now checked the week 9 GA solution are not uploaded.
Okay. We will upload it. Just wait for one day. It will be uploaded. Then you can check your answer.
Even I have a doubt, ma'am. So,
Week 9 GA?
yes, ma'am. 9G question number 13.
Okay. So it will be uploaded. Then you can check the solutions. Okay. Otherwise, you can ask. We can discuss it in the next doubt session.
Excuse me, ma'am.
Yes.
Ma'am, in the place of x in the above one which you just told us,
Hmm.
ma'am, here we put 0. If in every situation, then it will be 0, no? Means by default we choose 0 and 1. So if in the place of x we put 0, then in every condition this will become 0.
See, the thing is, when you calculate expectation, you have to look on the values that are taken by x. So in this particular case, okay, so this expectation is for this Bernoulli random variable, okay, not in general. So here you can see that it is taking two values, 0 and 1. And then you have to multiply it with the corresponding probabilities. So for 0, the probability is 1 minus p. Okay. And then we have to add the other value, multiplying with the corresponding probability. So it is 1 into p. Suppose if your random variable x is taking values 1, 2, and 3, okay, and the probabilities are suppose a, b, and c. Now you have to calculate the expectation. Then it will be 1 into a, okay, plus 2 into b, plus 3 into c.
Okay, ma'am. Means x, the values of x varies.
Yeah, so it may differ on, so x depends on, the value of x depends on the distribution it is following. So it may be different. It is not always fixed, okay?
Okay, ma'am.
Yeah.
Ma'am, can we
Okay,
discuss the week 9 doubts at the end?
okay, we'll see.
Okay.
Okay, so this was the Bernoulli random variable. Next, we have discrete uniform distribution. So discrete uniform random variable. So let x be a random variable, okay, that is equally likely to take any values. Any of the values 1, 2, 3 up to n. Okay, so here we are defining a random variable which is taking values 1, 2, 3, and similarly it is going up to n. And here it is written that this variable is equally likely to take any of the values. So now can you tell me what should be the probabilities? So equally likely means that all these values have equal chance of being occurred.
1 by
1 by
n.
9, 1 by n.
1 by n. 1 by n.
Yeah, so it should be 1 by n, right? So for 1, this is 1 by n. For 2 also it is 1 by n. Okay, so for all the instances, it will be 1 by n only. And if you want to check whether it is true or not, you can check that if you take the summation of all these values, okay, that will come equal to 1, right? When you add it n times. So here we have n numbers and you have to add it. So n into 1 by n, so that will become 1, right? And all these values are positive, so it follows all the properties of PMF. So it is a valid PMF here. So in uniform
Ma'am, excuse me.
distributions, yes.
Ma'am, Bernoulli theorem is the topic of week 11.
Yeah, that you're asking is actually binomial theorem, binomial distribution actually. So that will come in week 11.
Okay, ma'am.
Okay, so this is a PMF for discrete uniform. Okay. Now again, we are studying the topic expectation. So we will find the expectation of this random variable. Now tell me what will be the expectation of this?
1 by n plus 2 by n.
Yes. So the value of x is 1 and then the probability is 1 by n. Then the other value is 2 with probability 1 by n. Then it is taking value 3
A by
with
n.
probability 1 by n. Okay, similarly, n
Up.
into 1 by n. Okay. So you can take 1 by n as common. So it will be 1 plus 2 up to n. Now you know the sum of n natural numbers.
N
Okay.
in bracket n plus 1 by 2.
Yeah, so it is n plus 1 by 2. Okay. So this will be n plus 1 by 2. So this is the formula for expectation of uniform distribution. Okay, is it clear to everyone?
Ma'am, using this formula, we can find any expectation n
Yes.
1 by 2.
Yeah. Yes. So this formula is in general. Okay. So if you have any discrete random variable, you can always use this formula. Okay. And for continuous variable, we will study in the upcoming weeks. So there, this summation sign replaced with integration. Okay. There also we have to do this thing that x with multiplication, the corresponding probability. But there, since we have continuous variables, so we will do integration instead of summation. So by using this formula, you can find expectation for any variable x.
Ma'am, what's the difference between the first topic that you said and the second topic that you mentioned?
Which first and second topic?
The ma'am, initially you mentioned an expectation and Bernoulli, that something, and then there was a summation sign.
Yes.
And this one that we just did, the discrete. Ma'am, the second one is for the discrete uniform random variable, and the first one is for what?
Both are discrete random variables. See, don't get confused. See this, first of all, what we have seen the expectation. So whenever you have a random variable, okay, so you have a discrete random variable x. So what do you mean by discrete random variable first? So a discrete random variable may take any countable number of values, right?
Yes, ma'am.
Okay. So it can take some values. So suppose it is taking values x1, x2, up to xn, suppose. And there will be some probabilities associated with it. Since it is a random variable, so some probabilities will be associated with these values. So what we are doing, we have to take all the values of x and we have to multiply it with the corresponding probabilities. And then we have to take summation of it. So that's how we calculate the expectation in general for any random variable. Okay.
Okay.
Now we have seen these Bernoulli random variable and uniform random variable. Now you have to see the values taken by x in this PMF and the probabilities. So we are just putting the values in this formula only. Okay, we have to use this formula only and we have to calculate the expectation for Bernoulli random variable and for uniform random variable. Okay, so you
Okay,
can
ma'am.
see Bernoulli takes only two values, 0 and 1, and these are the probabilities. So we have calculated like this: 0 into 1 minus p plus 1 into p. Okay, so this is the expectation for Bernoulli random variable. Now discrete uniform. So it takes values 1, 2, 3 up to n with these probabilities 1 by n. So now we have to calculate the expectation. Again, we will do x into probability of x and we have to add it for all the values of x.
Yes, ma'am.
Okay. Is it clear to everyone?
Yes, ma'am.
Okay. Next we have expectation of function of a random variable x.
Excuse me, ma'am. I want to know where we can get this document that right now you're creating. The link
Yeah, this will be uploaded on the portal.
under which section, ma'am?
Under supplementary content, there will be one section of live session notes. There it will be uploaded.
Okay, okay, ma'am.
Okay, so next we have expectation of function of random variable. Okay. So suppose you have any function x. Okay, first of all, you have any variable x. Okay. And then on the basis of that random variable x, we can have any function of x. So first of all, let x be a discrete random variable. Okay. So which takes values. So suppose it takes some values that we don't need to write here. We can write it in general. So suppose x is a discrete random variable and gx is some function of x. So this gx can be suppose x square, okay, or x plus 5 or x square plus x. So these are actually the function of x. So do you all know the function of x? What do you mean by function of x?
Yes, ma'am. We give some input value and we get some output as
Yeah.
in using the function.
Yes. Okay. So we can have some function of x. You have a variable as x. Then you can have function gx. Now what you have to do, you have to find the expectation of this function of x, which we are writing as gx. So now how can you calculate the expected value for this function of x? So the formula for it is you have to write this gx. Okay, you have to put the values in that function of x formula and then you have to multiply it with the corresponding probability of x. Okay, and the range will be of x only. Okay, so this is how you can calculate the expected value for a function of random variable. Okay, anyone has any doubt?
Ma'am, can you repeat once again?
Can I please explain this using example?
Okay. So suppose you are given, first of all, you are given some PMF of X. So suppose X is taking values, suppose 1, 2, and 3. Okay, this is just a random example. Okay, and suppose it is taking these values with probability, suppose A, B, and C. Okay, now the function gx, suppose it is defined as x square plus 1. So this x square plus 1 is the function of x, right? Now you have to calculate the expected value of gx. Now the formula is that you have to take the summation over gx in multiplication with the corresponding probability. Okay, so what you have to do, you have to put the values in this function and you have to multiply it with the corresponding probability, and you have to take summation. What will you do? So the first value taken by x is 1, so you will put 1 here, so this will become 2 into, and at 1 the probability is a, right? So you have to put x equals to 1 in this equation 1. Okay, so this will become, when you put x equals to 1 here, so 1 square plus 1 will be 2, and the probability is a, right? Then the next value is 2, so you have to put x equals to 2 in this formula again, x square plus 1, which we have written here. So this will become 2 square plus 1. So this will be 5. And then you have to multiply it with the corresponding probability. So probability that x taking value 2 is b. Okay. Then you have to put here x equals to 3. So this will become 3 square plus 1. Right. So 3 square plus 1 will be
10.
10. Right. And then we have to multiply it with what?
C.
C, right? So it will be 10 into C. Okay. So this is how we calculate the expected value for a random variable of x. Sorry, function of random variable of x. Okay. So we will see the questions and then we will solve it.
Got it, ma'am.
Okay.
Okay,
Now
tell
there
me
are,
what is the use of this thing?
so suppose sometimes you have a random variable. Okay. So on the basis on, like, there will be some another random variable y which is actually associated with it. So which is actually kind of based on this random variable. So now if you want to find the expected value for this random variable, so by using the PMF of x, you can calculate it.
Okay, fine, fine.
Suppose there are two students, okay, which are getting some marks. So suppose student number 1, so you are saying that this is a random variable x. And for the second students, you are saying that this student has got the marks, 2 marks more than this student. So suppose the marks taken by student 1 is suppose ABC. So the marks taken by the second students, which we are denoting as y. So this will be A plus 2, B plus 2, and C plus 2, right? So like this, we can define another random variable, which is actually based on the previous one. And then
Okay.
by using the old one, we can find the expected value for the second variable. Okay. Now
Ma'am.
there are some
Okay, got it.
properties of it. Yeah. So there are some properties for expectation. So suppose if A and B are constants, okay, then expected value of AX plus B. Okay. So this is equal to A times expected value of x plus b. Okay. So since b is a constant, so when you take expectation over b, so the expected value of a constant is that constant only. Okay. So this is how it becomes like this. Okay, is it clear to everyone?
Ma'am, can you please explain this once again?
Okay, so we have a random variable x and these a and b are some constants. Suppose a is 2 and b is suppose 5. And you want to calculate the expected value of this ax plus b, which is 2x plus 5 here, suppose. So then it will be equal to a times expectation of x, which means for this, it will be 2 times expectation of x plus b. So here b is 5. So now what you have to do, you have to actually calculate the expected value of x. Okay. And then just put the value here and then you can get the expected value of this thing, this quantity. Okay.
Okay, ma'am. Ma'am, this is what colonially.
Yes.
Okay, ma'am.
Okay. So you can actually associate it with this thing that in week 3 you have studied about the mean, right? So there we had variables like x1, x2 up to xn. And if you calculate the mean of these variables, it is x bar, right? And when you multiply it with some constant, ax1, ax2 up to axn, and if you calculate the mean of these variables, right, then it was a times x bar. If you remember, this is also the property of mean. Okay, so the same thing is used here also. Do you agree with this if you remember week 3?
Yes, ma'am.
Okay, yeah, so it is the same concept used here. Okay, next we have variance. So till now we have seen the expected value of random variables. Now we have variance formula. So already we have studied variance in week 3, right? Now here we have to study the variance for random variable. So suppose x is a random variable. So x be a discrete random variable here. Okay. Then how we can calculate the variance of x? This is actually expectation of x minus mu. So we can write that x be a discrete random variable with expected value mu. Okay. So mu is actually the expectation of x. Okay. Now we are defining the variance of x. So this is x minus mu whole square. Okay. Now you can open this formula. So it will be expectation of x square plus mu square minus 2 mu x. Okay. Then it will become expectation of x square plus expectation of mu square. So what will be the value of expectation of mu square?
And mu must be a constant.
Yeah, so mu is a constant. So when you take expectation of a constant value, it will be same. Okay, so it will be mu square only. Then here 2 mu is a constant and this x is a variable. So this will become 2 mu expectation of x. Okay. Now this is expectation of x square. Okay. Plus mu square minus 2 mu. Now we already know that expected value of x is mu. Right. So we can put the value here. Now this is expectation of x square plus, so this is mu square. Okay. So minus 2 mu square plus mu square will become minus mu square, right? We can just solve it. It will be minus mu square. So this is the formula for variance of random variable x.
Expectation of x is mu. It is given in.
Yes, yes. It is expected value of x.
Ma'am, if you don't mind, can you explain it once again, please?
Yeah. So this formula for variance is expected value of x minus mu whole square. So this mu is nothing but the expected value of x. If you don't want to write mu, you can simply write expectation of x here also. Okay, that's your choice. No problem.
What is variance actually? Means what is use of variance?
So variance actually tells you about the how much that variable x is varying. Okay, the variation in that variable. So this variance is nothing but it is same as that we have seen in week 3 already. Okay, so it tells you about the variance actually means the variation. So how much this random variable x is varying, how much different values it is taking. So that gives you an idea about that.
Ma'am, this is same variance as that we studied
Yes,
in
yes, it is
last
same.
week.
Yeah, yeah, it is same. Okay.
Ma'am, then I will take expected value here.
Yeah, this mu is actually expected value only. Okay.
Ma'am, in the question it is mentioned that expected value is this, then find variance.
See, that depends on the question. Maybe the PMF is given, you have to calculate the expectation first and you have to calculate the variance. But yeah, some information will be given to you for calculating the variance. Okay.
Okay.
So that might vary from question to question. Okay, so this is the formula for variance. So this mu square, if you don't want to write mu, you can just write this is nothing but variance of x is equals to expectation of x square minus expectation of x whole square. Okay, now you should be clear with this thing that these two values are not same. These two are different. Okay, this is x square and then we are taking the expectation, the first one. And the second one is the expectation of x we are taking and then we are taking the square of it. So these two things are not equal to each other. Okay. Now is it clear to everyone? Now if you have, if you remember week 3 again, so all these concepts are from there only. So these, if you know the mean and variance, you can understand the expectation and variance here also. So
Ma'am?
again, we have some properties. Yes.
Yes, ma'am, here EX square is the expected value of x square. And in the other term, we find expected value, then whole square it.
Yes, yes.
Okay, ma'am.
Okay. So as we have seen these things, okay, when you multiply a constant to the variable and when you add a constant to the variable, the effect on expectation. Similarly, we have to see it for variance as well. Okay. So again, if A and B are constant, okay, so what will be the variance for A times X plus B? So can anyone tell? Just relate it with the variance that you have already studied in week 3.
A is variance of x.
A times variance of X.
Ma'am, A square, A square.
Yes. Yeah, so it will be A square times variance of x. And this b, if you take the variance of a constant, okay, so variance actually tells you about the variation, right? And this is a constant value which is not changing, which means there is a no variation. So variation is 0, which means variance is 0. Okay, so that's why it is like this. Okay, so if you add a constant, then variance will not be affected. Okay, now is it clear to everyone? Okay, now next we have that if you have independent random variables. Okay, so if x and y are independent random variable, Okay. And you have to calculate the variance of x plus y. So what it should be? So these two variables, x and y, are independent. So the variance will be the summation of their individual variance. Okay. Now you have studied variance, so you should know the
First
standard
one
deviation.
where A and B are constant. I didn't get how variance of AX plus B is equal to A square into variance of X. Can you please repeat that?
Okay. So suppose we have, okay, again we will go back to the week 3 if you remember. If you have x1, x2 up to xn, right? And the variance for these is suppose sigma square. Okay. And what we do, we multiply with a constant to all the values. Okay. Now, if you have to calculate the variance of this, what will you do? One thing is that you can calculate the variance of this data. This is the long method. Otherwise, if you already know the variance for these values, x1, x2 up to xn.
Constant square into old variance.
Yeah, so it is constant square times old variance. Okay. So this is the same thing.
Ma'am, here expectation is not applied.
Okay, you want me to solve it by using this formula, right?
Yes, ma'am.
Yeah, that we can use. So that we will use to calculate the variance of x. This is what we are doing. We are multiplying with a constant and we are adding a constant. And now you have to calculate the variance of this. So by using the variance of x only, you can find the variance of this quantity. If you want to apply this formula, you can use that also. But this is the shortcut. This is the property that you can use. Okay.
Okay.
So you don't need to calculate the variance of ax plus b and then expected value of this whole square. That will be too lengthy. You just
Ma'am, we
calculate the
can
variance
do
of
it
x.
simply, just like in week 3.
Yes, yes. So you always use the property. Otherwise, it will be too calculative.
Okay, ma'am.
Yeah. Okay. Now, if you know variance, you should know standard deviation. So standard deviation of x is nothing but the square root of variance of x, right? Okay, so this is how we
Yes,
can
ma'am.
calculate the standard deviation. So these are all the topics in week 10. Now just solve some questions. So this is your question number 1. Try to solve this question. Okay, so in the question it is
5 by
given.
2.
So in a box
2.5
of
by
2.5 is what expectation?
yes.
Okay, we'll see. So here the question says, in a box of numbered balls, balls are numbered 1, 2, 3, and 4 such that the probability of drawing a ball is proportional to the number on the ball. Okay. Now, if a ball is drawn at random from the box, then what is the expectation of number on the ball drawn? Okay. So here we can assume one random variable x, okay, which will be representing the number on the ball. Okay, so suppose xi represents the number on the ith ball. Okay, so what values xi is taking here?
Ma'am, is it 3?
What values xi is taking?
1, 2, 3, 4.
1, 2, 3, 4.
1, 2,
1, 2, 3, 4.
1, 2, 3, 4, right?
Yes, ma'am.
So x is taking values 1, 2, 3, and 4. And what will be the probabilities? So it is given that the probabilities of drawing a ball is proportional to the number. Okay. So this probability, suppose I denoted with P. So this is proportional to the number 1. For this, it is proportional to 2. Okay. So when you convert this proportionality sign into equality, there comes a constant value, right? So this will become 2k, right? And then this is 3k, right? And for, are you getting my point? So the probabilities are proportional to the number. When you convert it into an equality sign, this will be a constant comes here, right? So now
Yes,
we can
ma'am.
write it like P1, P2, okay, because these all are not same. Now we can write the PMF. So X is taking value 1, 2, 3, 4 with probabilities K, 2K, 3K, and 4K. Okay. Now, if you know the property of PMF, you can find the value of K.
Yes, ma'am. By equating it to 1, summation of.
Yeah. So, summation of these values should be equal to
P
1.
will be 1 by 10.
Yes. So, this should be equal to 1, which implies that K is equals to 1 by 10. Okay. Now, what we have to do? We have to calculate the expected value. So, expected value of X is summation of X into probability. Okay. Now, at 1, what will be the probability? It is 1 by 10, right?
0.1.
So it will be 0.1. Then for 2, the probability will be 2k. So 2k, which means 2 by 10. Okay.
0.2.
So it will be 0.2. Then for 3, it will be 0.3. And for 4, it will be 0.4. Is it clear to everyone?
Yes, ma'am.
Okay.
Yes, ma'am.
Now I just do this calculation and tell me the value.
Three, ma'am.
So it will be equal to 3. Okay. So the expected number on the ball will be 3. Okay. Is it clear to everyone? Any doubt?
Ma'am, can you explain once how we find the value of K? Actually, there was a power cut, so I missed.
Okay. How we calculated the value of k,
Yeah,
or
that k to 2k, yeah, that entire thing.
okay, yeah, this thing. Okay. So in the question it is given that the number on the balls are 1, 2, 3, 4, and the probabilities of drawing a ball is proportional to the number on the ball. Okay. So the ball, okay, which is number 1. So the probability will be proportional to 1 only. So this is proportional to 1. When you convert it to the proportion equality sign, it becomes a constant terms comes, right?
Yeah, I got it.
Okay, so this will be equal to 1. Now for the ball which has number 2, it is probability is proportional to 2. So then it will become 2k. Similarly, it will become 3k and 4k.
Okay.
Okay, so that's how we can write the probabilities.
Mhm.
Now just use the property of PMF. So the summation should be equal to 1, right? The summation of the probabilities. So when you put it equal to 1, from there you can find the value of k. Okay. Now you
Understood.
just have to use the formula for expectation and you can calculate it. So you have to multiply x with the corresponding probabilities. So first value is 1 and the probability is k, which is 0.1. Then we have 2. So probability is 2k. So 2 into 1 by 10, which will be 0.2, right? Then we have 3 into 3 by 10, which will be 0.3. Similarly for 4. Now is it clear?
Yes, ma'am.
Okay. Okay, we can move on to the next question then. This is your second question. Now try to solve this one. So here also, in a box of numbered balls are numbered 1, 2, 3, and 4, such that the probability of drawing a ball is proportional to the number on the ball. So this scenario is same as the question number 1. But here we have to find if a group of 3 balls is drawn at random with replacement from the box, then what is the expectation of sum of the numbers on the balls drawn? So in the previous question, we were selecting only one ball, right? And we were calculating the expected value of the number that will be written on the ball. Now here what we are doing, we are taking 3 balls and we are interested to know that what will be the expected number of the summation of those 3 numbers. Okay, you have 3 balls, okay, and all the 3 balls will have some number, maybe suppose 1, 3, and 4. So we are interested to know the summation, and then we are calculating the expected value of the summation of these 3 values. Okay. Try to solve it. So here also we can say that let xi be the number on the ith ball drawn. Okay. So what will be the expectation of xi? So xi, be careful. Read this line again. What xi is representing? Xi be the number on the ith ball drawn. So that will be same as, so this thing we have actually calculated in question number 1. In question number 1, what we have calculated? The expectation of the number on the ball. Right? So this thing we have already calculated. In the previous question, we were selecting only one ball. In this question, we are taking 3 balls. This is the only difference. Okay. So the expected value for the number on the ball, that will be 3 only. Okay. That we have to calculate by the same method. Okay. So this is 3. Is this thing clear to everyone?
Ma'am, can you please repeat this? What you say just now?
Yeah. So here just see what is xi. We are taking the expectation of xi. So what xi is representing is number on the ith ball. Okay, we are selecting 3 balls. So it is actually representing what can be, it is representing the number on the ball. So here we are selecting 3 balls, right? In the previous question, we were selecting 1 ball only, right? So these variable x was representing the number on the ball, right? So xi can be like x1, x2, x3. So I will be 1, 2, 3 because we are taking 3 balls. Okay. Now we have already calculated the expected value for number on the ball, which we are drawing. Okay. So number on the ball, the expectation for this thing is 3 that we have already calculated. Now do you understand it? Just read this question again. This part first. So what it is saying, if a ball is drawn at random from the box, then what is the expectation of number on the ball drawn? Okay, we are drawing one ball and we are interested to know what can be the expected number on the ball. We have number 1, 2, 3, 4. So what can be the expected number? Okay, so in the second question also, xi is representing the number on the ith ball. So here we are selecting 3 balls. So it is for 3 different balls. Okay, so x1, so we can have 3 variables, x1, x2, x3. Okay, so x1 will be representing the number on the first ball drawn, x2 will be representing the number on the second ball drawn, and x3 will be the number on the third ball drawn. Okay, so for the first ball, what can be the expected value for the number of the number on the ball?
3.
3. Okay, this thing we have already calculated in the previous question. Okay.
Yes,
So
ma'am.
here I is going from 1, 2, and 3 because we are taking 3 balls. Okay. So this is variable xi. Now we are interested to know sum of the number on the balls. So we can define another variable y. So let y be the random variable. Okay. Representing the sum of the numbers on the ball drawn. Okay, so we are taking 3 balls. So y is representing the summation of those 3 numbers on the ball. Okay, is this clear? What is y representing? Okay, so we are taking 3 balls. Okay, so suppose the number is x1, this is x2, and this is x3. So y is representing So y is actually the summation for these three numbers. Okay. So x1 is actually representing the number on the first ball, x2 representing number on the second ball, x3 is for third ball. Now y is representing the summation of all the three. Okay. Now in the question, we have to calculate the expectation of the sum of the numbers on the ball drawn. So what we actually have to calculate for this thing? Can you tell me what we have to calculate here?
Ma'am, we can do that addition rule of expectation.
Yes, that we can do, but what we have to calculate here first? What we want to calculate?
E of x1, which is given 3, means which we find in the previous question.
Just to
It
calculate
is
y.
E of x1 or E of xi.
It is xi. So for all the three, see, it is same for all the three. Expectation of x1, expectation of x2, expectation of x3. This is 3. So in general, we write it like this. Instead of writing for all the values, we just denote it with I. Okay, we just give some index.
Ma'am, means it is the expectation of taking one ball. So for every...
No, it is not expectation of taking one ball. It is the expected value for the number on the ball. Okay?
Okay, ma'am. The number which is written on the ball.
Yes, it is for the number on the written on the ball, not for drawing one ball. Okay. Now, y random variable y is representing the summation of the numbers which are written on the three balls we are drawing. Now, just tell me what I have written in the solution part and what is asked in the question, what I have to calculate now.
Expectation of y.
Yes, we have to calculate the expectation of y. So it is written that what is the expectation of the sum of the numbers on the ball. So sum of the number on the ball is represented by y here. So actually we have to calculate expectation of y now. So expectation of y will be equal to expectation of x1 plus x2 plus x3. Now it is the property that if you have summation of variables, the expectation of the summation of the random variable will be the summation of their individual expectations. So this is a property which is true always. Okay. Now we know these values, expectation of x1, expectation of x2, and expectation of x3, right? That we have already calculated in the previous question, which is equal to 3. So this is 3 plus 3 plus 3. So that will be 9. So this is our answer. Now, do you have any doubt?
Ma'am, you was just written that
No, ma'am.
expectation of x1 equals to expectation of x2 equals to expectation of x3 equals to 3. And then, may can I say that expectation of x4 equals to 3?
Yes, that will also be same.
Okay.
Excuse me. I can get any three possible combinations.
See, I is representing, see, here you are representing drawing 3 balls. Okay. So that's why I have written I is going from 1, 2, 3. If you are taking, suppose 4 balls, then I will be 1, 2, 3, 4. And then expectation for x4 will also be 3 only.
No, I am asking it can be 2, 3, 4 or 1, 2, 4 or 2, 3, 3 to 4.
I.
Yeah, three balls can be any.
See, you are getting confused. It is not the number. It is the first ball, second ball, and third ball. It is not the number written on the ball. You are getting confused by it. Maybe.
Yeah. Okay.
Okay. Maybe you are selecting first ball and the number written on the ball is 3. So these I equals to 1, 2, 3 is not the number on the ball. It is the first ball, second ball, and third ball.
Yeah, ma'am. Now I got it.
Okay, now is it clear? Yeah. Anyone
Ma'am,
else has
the
any doubt?
EXI is the expectation of taking ball, and we are taking 3 balls. That's why
No,
we add
no, no,
it.
no, no. Yeah, here we have added it. This expectation of xi is like you are selecting a ball, and what can be the expected number written on the ball.
Okay, ma'am.
Okay. So for first ball also, it will be same for second ball also. Okay. So x1, x2, you just see the first question. So in the first question, it was asked that if a ball is drawn at random from the box, so what is the expectation of number on the ball drawn? Okay, we are not interested in how many balls we are drawing here. We are just want to know if we select a ball, okay, so what can be the expected number here? So it can be 1, 2, 3, 4. So we have to find the expectation here. So by using the PMF, we can calculate the expected value. Okay. So
Ma'am,
whenever you draw, so for any
expectation
number of
of-
the balls.
means it is the expectation of the number which is written on the ball.
Yes, it is. Yeah. Number which is written on the ball. Okay. It is not the how many balls you are drawing. Okay.
And
It is not that.
in the second question, which is asked to draw 3 balls,
Hmm.
here the expectation is same for 3 balls. That's why we added.
Yes. No. If it is different also, then also you can add it. See this property. This is the property of expectation. If you have two variables, suppose x and y. Okay. So, and you want to calculate expectation of x plus y, then it is always equal to expectation of x plus expectation of y. This is the property of expectation. Okay, regardless of the
Ma'am,
question, you can always use it.
isn't this only valid for independent events?
No, see, for expectation, this is always valid. For variance, it is for independent random variables only.
Okay, ma'am.
Yeah.
Ma'am, what if in this case you just given with replacement, right? What if in this case you just given without replacement? They're just taking the first ball without keeping it. They're just taking the second one and without keeping it, and
Yeah.
they're just taking the
Yeah,
third
okay.
one. What
See,
happens?
in that case, without replacement, we have to use conditional expectation actually. But those concepts are not here.
It's out of syllabus.
Yes, that will be out of syllabus.
Ma'am, for this week alone, or it will be there in the next week?
The thing is, if you're asking about the conditional expectation, like some questions that can be solved by conditional expectation, so those kind of questions will not be asked. So in probabilities, you have
No,
seen
we
with
can still
replacement, without
solve this with the
replacement.
normal expectation, right?
You can solve it, but you will require some other things also. Okay, you can try and try solving that after the session. Okay, and see how it works.
Can you repeat what you said now?
I'm saying that try solving in that way, that question, and see how does it work. Okay.
In what way, ma'am?
Just try to do it on by your own.
Ma'am, these are activity questions?
What?
Ma'am, where we get this question? These are activity questions?
No, these are not activity questions.
Then, ma'am, where we will get it?
So you will get this PDF will be uploaded. You can see there.
Okay, ma'am.
Okay, is it clear now to everyone? Okay, so this was the property of expectation which you can use always. For variance, x and y, that should be independent, then only you can use that. Okay, this property. So here x and y should be independent, then only you can use that. Otherwise, the formula for expectation is like, so there a covariance terms comes. if the variables are not independent. Okay, so that is not in your syllabus actually. So we will use this formula for
Ma'am, I have
independent.
a doubt. What will be the variance of ax plus b whole square?
So in that case, you have to open the square and just see variance of ax plus b whole square, right?
Yes, ma'am.
Yeah, you just open up the square and some terms will come, right? It will be a square x square plus b square, right?
So
Right?
according to me, I think like we should get a to the power 4 into vx square plus 2ab whole square, 4a square b square bx, variance x.
It will be
Because
this, right?
yeah.
Okay. So then it will be a power 4 variance of x square and b is a constant, and then square of this variance of x. Okay. Okay, now try solving this question. So here you can see that it is based on the function of a random variable x. So gx is the function of a random variable which is defined like this, x square plus 3. Okay, and now the PMF of x is given in the question. So you just have to use the formula and try to solve it. And you can also use the properties of expectation. Okay. So always try to use the properties if it can be used in the question. That makes your calculation easy. So first of all, expectation of gx. Okay. So if I put the value of gx, this is x square plus 3, right? Now if I open the bracket and take this expectation inside the bracket, then what will the values? What will be the values here?
Expectation of x square plus expectation of 3.
Expectation of x square plus expectation of 3 will be 3 only,
Yeah.
right? Now what we can do, we can find expectation of x square. So x square is also a function of x, right?
Yes, ma'am.
So here there might be two ways to solve this question. Either you take this one as okay gx and you put the values here, and
Yes, ma'am, I do
okay.
that way.
Yeah, so that is also correct, no issue. Okay,
I have
otherwise you use the
5
property of
I got
yeah,
5.
that is yeah, you can solve by that method also. Otherwise I'm using the property, so it will make the calculation a bit easy. You don't have to add 3 in all the terms, right? So if you remember the properties,
Ma'am, it's
you always use it.
4.12.
Okay, I'll solve and check. Now what we have to do, we have to calculate expectation of x square. So according to the formula, it will be x square probability that capital X is taking value, some small x, right? Now the PMF is given to us, -1, 0.1. So this is a PMF. We just have to put the values. Okay. So just plug in the values. So for -1 square, okay, probability is 0.1. Next we have 0, probability is 0.15. So 0 square into 0.15. Then we have 1 and 2 with probability 0.3 and 0.45. So 1 square, 0.3 plus 2 square into 0.45. Okay. So this will be 1 into 0.1. This will be 0, 0.3. This will be 1.8, right? So this will be 2.2. Expectation of x square only. This is not the final answer. Okay. Final answer you will get after putting the values here. Okay. Now, expectation of gx that we have to calculate. This is equals to expectation of x square plus 3. Okay. So this will be 2.2 plus 3, which is equal to 5.2. This is the answer. Okay. You can also find it like this, that expectation of x square plus 3. So that will be equal to what? Summation of x square plus 3 probability x is equals to x. So you can find by using this formula also, and you will directly get it. So both the methods are correct. Okay.
Ma'am, in this case, as you said in the second method, if I try get 4.12.
No, ma'am, I am also doing through second method. I got 5.2.
Yeah, it will be 5.2 only. Okay, both the methods will give you the same answer.
Maybe calculation error has occurred.
Yeah, you might be mistaken somewhere. Okay, is this question clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay, now try solving this one.
Ma'am, this is a normal probability question. Means your expectation is not used. No?
Yes.
Okay, ma'am.
Yeah, so the question is, in a box, there are 10 chocolates, of which 6 are milk chocolates and 4 are dark chocolates. 2 chocolates are drawn at random without replacement from the box. Okay. So find the probability that one dark chocolate is drawn among those 2 randomly drawn chocolates. Okay. So we can take, let x be a random variable. Okay. Representing number of dark chocolates okay drawn from the box. Okay, so X is representing the number of dark chocolates drawn from the box. So find the probability that one dark chocolate is drawn among those two randomly drawn chocolates. So which means we have to calculate the probability that X is equals to 1, right? So we can, this is a normal probability question, you can see. So how many balls we are selecting? Total we have 10 chocolates, not balls, sorry, chocolates. So we have 10 in total, out of which we are selecting 2, right? Now we have to find that there should be only one dark chocolate. So how many dark chocolates we have in total?
Ma'am, each 24 by
4.
45 is answer.
So this will be 4C1, okay? And then since we are selecting 2, so from the remaining 6 milk chocolates, we will be taking 1 chocolate, right? Now we can calculate it. So this will be 4 into 6 divided by 10
4
into,
divided by 45.
yeah, I'm solving it, 1 minute.
Ma'am, 24 by 45 is the answer.
So this will be 48 by 90.
I got 3.
So it will be 0.53. You can match with this answer. This is the correct one. Okay, so this is the probability. Is this clear to everyone?
Yes, ma'am. Ma'am, can we go to the GA9 doubts?
No, we will complete these first and then only.
Okay.
Otherwise, you can you can ask the doubts in the doubt session, okay?
I also do the same thing, but first I individually calculated 4C1 into 6C1 and 10C2 and then divide, but I got 24 by 45.
This term is same for you, right?
Yes, ma'am. Means
Then
I
you should get,
calculate 4C1 into 6C1. I got 24 and individually calculated 10C2, which I got 45 and then 24 by 45.
So 24 by
That is the
45 and 48 by 90 are same, right?
simplified ratio only.
yeah, you will get the same answer.
0.53.
Okay.
Okay, then the next question. So here you have to calculate what is the expected number of dark chocolates drawn. Okay, the same thing is there. In a box, we have 10 chocolates, 6 of which are milk chocolates and 4 are dark chocolates. And we are selecting 2 chocolates. So now we have to calculate the expected number of dark chocolates drawn.
It was 0.8.
Okay, let's solve it. So this is the sub part of that the previous question only. So we were taking that X be a random variable which was representing the number of dark chocolates drawn from the box. Okay. So and here also we have to calculate the expected number of the dark chocolates. So actually we have to calculate the expectation of X, right? Again, I'm writing it here still that X be the random variable representing number of dark chocolates drawn from the box. So we have to calculate expectation of x, right? This is something we have to calculate. Now, according to the formula, expectation of x is summation of x into probability of x. So we should know the values taken by x and the corresponding probabilities. So can you tell me what values x can take here?
0, 1, and 2.
0, 1, 2.
0, 1, and 2.
So we are selecting two chocolates. We are drawing two chocolates. Okay. So maximum it can be two, right? So either it will be no dark chocolate or 1 or 2. So x will belong in this range. So it will be 0, 1 or 2, right? Because we are drawing two chocolates maximum. Now we have to find the probability. So we can see that probability x equals to 1 we have already calculated. So we have to calculate probability of x equals to 0 and for 2. And then by just plugging the
So
values
0,
into the
it
formula,
will
we can.
obviously be 0 because it will get multiplied by 0.
Why?
We're calculating
Calculate it.
expectation, right?
Yeah, that part will be 0, but you have to calculate probability of, yeah, that will be 0. Yeah, so we don't need to calculate it actually.
Yeah.
Yeah, correct. So when you multiply it, it will ultimately be 0. Still, you can calculate this probability if you want. So if you have to calculate, how will you calculate it?
It will be 0.6.
So this is 10C2 in total. We are selecting 2 chocolates out of 10 and 0
Oh,
dark
sorry,
chocolates.
6C2 by 10C.
Yeah, so out of the total 4 dark chocolates, we are
0.33.
selecting 0, then 6C2. So you can calculate it. Then probability of x equals to 1 that we have already calculated. So it is 0.53. Now calculate for x is equals to 2. So from the 4 dark chocolates, we are taking 2, and out of the remaining 6, we are taking 0. Okay.
0.26. Sorry, not that. 0.13.
Yeah. And this value?
That's, I think, 0.13.
It is 0.33 something.
0.33.
Yeah.
Yeah, now just put the values. So expectation of x. So this is summation of x into probability. This. So 0 into 0.33. Okay. Then probability for 1 is 0.53. Then for 2, we have 0.13. So this will become 0. So in the exam, we don't need to calculate it. We already know that it is going to be 0. But here, just to show, I have calculated it. So then it will be 0.53. Okay.
Now it will actually be 0.27 because like the 3 was getting which was it was 0.13333 and now it's multiplied, so it's going to be 0.26666. So it will like going to become 7.
Yeah, so we can round it to the 2 decimal places. Okay. Okay, now is it clear to everyone?
And in this question, how you got means we have to find expectation.
So how what's your question? Repeat, please.
Ma'am, means actually I didn't find expectation. I only find probability. Means how you get that we have to find expectation here.
See, it is written in the
I
question.
understand that.
It is written here.
Oh,
That what is the expected number
ma'am.
of dark chocolate stone. Okay. In the previous question, we just have to calculate probability, but here it is written that we have to calculate expected number.
Okay, I overlooked it. Okay.
Anything else in this question?
No, ma'am.
Then solve this question.
Ma'am, the answer is 3.
Okay. So here, the past records of a football club in golden goal matches are analyzed. Assume that the result of a match is independent of the other matches. So we are given this variable xi, where x0 if team loses, and if x is equals to 1 if team wins. So what is the expected number of wins in 5 matches? Okay.
So we are already given the probability of wins. We can simply just multiply it with the number of matches.
Yeah, we can simply do that. But okay, we just go with the process. Okay, so that everyone can understand it. So here it is written that xi is a random variable associated with the ith match of the club. So we can say that xi so that is written that xi is a uh, random variable which is associated with the ith match. So we can calculate the expectation of xi here, right? So expectation of xi will be 0 into 0.4 plus 1 into 0.6, right? Which will be equal to 0.6 only. Okay. So this is
Yes,
for
ma'am.
one match. Now we have to find that what is the expected number of wins in 5 matches. So we can define another random variable s, okay, which will be representing. So this is also a random variable which is representing the number of wins or we can say number of matches won by the football club in 5 matches, right? This is something we can define. So S will be equal to what? We can write. So it will actually be the summation
5
of,
into
yes, so it will be summation of xi. So here I will be going from 1 to 5, right? 1, 2, 3, 4, 5 because we are interested for the 5 matches here. So what is the expected number of wins in the 5 matches? So xi, suppose, so x1 is the first match, x2 representing the second match, right? Like this. So this will be, now we have to calculate the expected number of wins in the 5 matches. So it will be expectation of S, right? So it will be summation of expectation of xi. Now I is going from 1 to 5. So this will be summation I going from 1 to 5, and the expectation of xi is 0.6. So this is 0.6 that we have to add 5 times, right? So this will be 3. Just look this question again. So here xi is a variable which is associated with the ith match. Okay. So here we are interested in the 5 matches. So x1, x2, x3, x4, x5 are representing the 5 matches. And this expectation of xi, okay. So this is we can calculate for all the xi's, right? It will be same. So I is going from 1 to 5. So in general, we can write xi. So similar, first of all, we will calculate the expectation of xi, and then we just have to add it for the 5 different matches. So we can define the random variable s, which will be the summation of xi's, and then we can calculate the expectation of s and just put the values here, and you will get the answer.
Ma'am, a small term, ma'am. In this case, for losing matches, they just given 0, right? And for winning, they just given 1. Instead of for winning, they give 3, and losing, they give 5. Like that, any different numbers other than 0, 1, 1, it's possible. Because if we calculate the expectation elements, for losing match, we always get 0 only. If we for winning matches, we always get the probability of winning.
Yeah, so this is how it works. So this is a Bernoulli random variable. So expectation for Bernoulli is always P. Okay, if x
Yes,
follows
ma'am. But
Bernoulli
in this
random.
case, P has 2 things, right? P of probability, P of losing the match is 0.4. But if we calculate the expectation, means it becomes 0. If you calculate the expectation of winning, it gets like 0.6. We always get the value of winning probability, right? Why we are not getting
In
the losing
Bernoulli's
match?
principle, we actually, the favorable outcome is 1 and the unfavorable is 0. So if you want to calculate the lose, you will have to make lose the 1 and wins the 0.
Oh,
That is
okay,
the first
fine.
rule of the Bernoulli's.
Then for losing match, we need to calculate the winning minus probability P of losing.
No, you simply just need to, like in the question, it's written x equal to 0 if team loses. You simply just need to put x equal to 1 if team loses. Probability will be answer.
As in this, if what if in this case losing matches is 5?
Sorry, what?
What is the probability that the losing match is 5?
Oh, 2. Expectation is 2.
How
See,
it will be? It will be 0 only, right? Ma'am, if we calculate the expectation of the number of losing matches is 5 matches, means then we'll be getting as 0 only, right?
no, not 0.
Now he's confusing with the Bernoulli's theorem. Like the first rule states that the favorable outcome should be 1, the unfavorable should be 0. So he's not changing the outcomes.
Yeah, so in that, see, if you are
Yeah.
here, see, we have 2 things, right? Success and failure.
Ma'am.
That depends on you how you want to define it. So here, success is taken as winning the match, and failure is taken as losing the match. Here we are interested in expected number of wins. So we are saying that x is equals to 1. Okay, this failure is winning the match, and 0 is losing the match. So the success is failure might be interchanged also. Maybe you are interested in losing the match, right? So maybe you can take it that success for us is when we lose the match, and failure is when when winning the match. Okay, so this success and failure, it can be defined on the objective of your, like what you want to find. Okay, so for different contests, it can be different. So here we will say that X is taking value 1 when it is losing the match, and it is taking value 0 when it is winning the match. Now you have to take this probability of winning and losing, and then you have to solve it.
Okay. Our inter
Okay.
should be get into as 1 and our success should get into as 1, failure should get as 0. It may be winning or losing.
Yeah, that you can interchange actually. So here we are representing that X is 1. So when in 1 is 1, when we are a team is winning the game. If you are interested in losing the game, you can interchange these values.
Okay, fine, ma'am, fine.
Yeah, so this success and failure is we can define, like it can be changed. It's not like success means always winning and failure is losing. It's not like that. It is just saying that we have two outputs, two types of outcomes. Now it depends on us what we are taking as success and what we are taking as failure.
Yes, ma'am. Now I got it.
Any other question in this?
No.
Yeah, solve this one. So here also we have the same information. What we have to find here, what is the variance of number of wins in 5 matches?
What was the formula of variance? I forgot.
So formula for variance is, suppose if you have to find the variance of x, it will be expectation of
x
x
square minus expectation of x
whole square. Okay, this is the formula for variance of x. So here we are interested in knowing the variance of number of wins in 5 matches. Okay. And you can also use the properties of variance that we have seen, that what will be the variance of ax plus b and all. Okay.
So will it be 0.24?
Okay, be careful what we have to calculate here. Okay. So we have to find the
wins of
variance
5
of
matches.
5 matches. Okay, not in the single match. So xi is representing the single match.
Yes.
And if you're interested in 5 matches, then we are denoting that variable as s. Right? So actually we have to find the variance of s here and not variance of x. But for calculating the variance of s, you have to calculate the variance of x. Right? Now just try solving it.
Sorry, ma'am, I lost my network.
So it should be, I think, 2.64.
It's 8.64.
No, you are doing 3 square minus 0.6 square. Should be e of x square.
I was just making that e of x square is 0.6 the whole square, right? Then becomes 0.36 minus 9. It's
Okay. See, let me solve it.
I think we need to find the variance of x and then multiply it with 5.
Yes. So we have to actually, first of all, we will calculate the variance of xi or x, and then we can calculate the variance for s. Okay. So be careful that we have to find the variance of number of wins in 5 matches. Now just look at this part again, that s is representing the number of matches won by the, like number of wins in the 5 matches. Okay. So actually we have to find the variance of s that we have defined here. So first of all, we will calculate the variance of xi. So variance of xi is equal to expectation of xi square minus expectation of xi whole square. Now expectation of xi we have already calculated, right? Okay, so expectation of xi we have calculated already. So it is 0.6. Is it clear to everyone? Actually, these two questions are like this is the main question and this is the subpart of it. Okay, so we have two subparts of the same question. So expectation of xi we have already calculated and it was 0.6. Now we have to calculate expectation of xi square. So again, look at the PMF. So it is taking two values with these probabilities. So 0 square into 0.4 plus 1 square 0.6, right? So again, it will be same as 0.6 only. Is it clear to everyone?
Yes, ma'am.
Okay. Now we can calculate the variance of xi. So this will be, just put the values in the formula here. So it will be 0.6 minus 0.6 whole square. So this will be 0.6 minus 0.36. So it will be 0.24, right? So this is the variance for xi, which means for the ith match. Now we are talking about the 5 matches, right? So you can see that these
So now we
matches,
should just multiply it by 5.
yeah. So remember one thing, that here it is written, it is given in the question that the result of match is independent of the other match. Okay. So all the matches, the result, the outcome, whether they are winning in the match or losing in the match, it is independent from the other matches. So now we are talking about the 5 matches. So variance in winning in the one match or here in the ith match is 0.24. Now we have to find it for the 5 matches. Okay. So in 5 matches, the number of winning is represented by S, right? That we have written in the first part of this question. So S is representing the number of wins in the 5 matches. Now we have to find the variance of number of wins in the 5 matches, right? So we have to find the variance of S. So S is defined as variance of S. And what is S? So S was summation of xi, right? Is it clear to everyone? I have just put the value here.
Yes, ma'am. Yes, ma'am.
Okay, now just so this can be written as like this. So how you can understand it? So this is actually variance of x1. So here I is going from 1 to 5. So we can write variance of x1 plus x2 plus x3 plus x4 plus x5 like this. Okay. Now since all the 5 matches are independent, so we can write it like this, variance of x1 plus variance of x2 up to variance of x5. And this thing we have calculated here. Okay. This is variance of xi. Okay. So variance of xi where I is going from 1, 2, 3, 4 and 5. Okay. So this is 0.24. Now we have to add it 5 times or we can multiply it by 5. Both the things are same, right? So this is equal to what? 1.2. Okay. Now is it clear that why we are multiplying it actually? So this is the concept behind it.
That's fine.
Is it clear to everyone now why, how we are solving this question? Anyone has any doubt?
No, no.
Okay. So whenever this kind of question is given, you just try to understand what it is given in the question and what we have to find actually. It's not always that x is given and you have to find the expectation of x and y only. Expectation and variance of x only. So maybe some function is defined of x, but it is not given to you directly. It will be written in some theory. So that you have to identify, and then you have to see what expectation and what variance you have to calculate. Okay, this is the last question. This is just a conceptual question. We have already discussed it actually. So which options will be correct here? So here let y equals to
Option
as
1
plus
and
b.
3.
Yeah, so expectation of y. So y is as plus b. We have to find expectation of y here. So expectation of as plus b. So these are actually the properties we have seen already. Okay, so this is our option number 1. And then which of the 2 and 3 is correct?
1 and 3.
Yeah, 1 and 3 correct. So variance of y will be variance of as plus b. Okay, so it becomes a square times variance of s, and the variance of b is actually 0. Okay, is that clear to everyone? So option number 1 and 3 are correct. Anyone has any doubt? In week 10?
No.
No.
Ma'am, can we check those 2 questions now from week 9?
GA questions, right?
Yes, ma'am. And can I share my screen?
No, just let me check. So according to you, the answer given is wrong.
Yeah. Like if you can clarify whether I am wrong or the answer is genuinely wrong.
Okay, I'll solve this question. Okay, so which option should be correct according to you? I'll check if it is wrong. We will correct it.
I actually wait. Let me just open it. Yeah, ma'am. So it's question 10. It should be option C, 0,
Okay,
1, 2,
which
3,
is the
4.
question number 10? Because for me it is an NAT question.
A box contains 7 red balls and 5 blue balls.
Okay, in which options are 1, 2, 3, 4 like this? Range is given.
Can I just share my screen?
No, you don't need to share.
No. So it's like given options are given as 1, 2, 3, 4, 1, 2, 3, 4, dot, 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 7, 0, 1, 2, 3, 4, and 0, 1, 2, dot, 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 7. And I think the
Yeah,
correct answer should be 0, 1, 2, 3. But they have given as 1, 2, 3 for the correct answer. Now, if we see logically, then there must be a case where no blue balls are picked, right? Sorry, no red balls are picked. It's said red balls. There can be a case where no red balls are picked. So it has to be 0 also.
1 minute. Yeah, so what is the answer according to you?
And 0, 1, 2, 3, 4.
Hmm.
Because if we see it logically, then X can also take 0, right? Because there is a
Yes.
possibility that
Yeah,
only
okay,
blue
okay.
balls are picked. And in the very next question, it
Okay,
said
I'll
that
see. Maybe the answer given may be incorrect. Okay, we'll check if the wrong answers are.
what do you think? Is it wrong?
No, it should be 0, 1, 2, 3, 4 because we can make the
Yeah,
possibility is there because that no ball is red.
yeah. And the
Yeah.
very next question, X denotes the total score in two throws, right?
Okay,
So the minimum value, the least value of X should be 2, right? So the correct answer which IIT Madras has given is that option
okay,
A, P of
okay.
X
So
equals.
maybe there is some issue. So that's why it is showing wrong answer. So okay, we'll check. So question number. Okay, this question, and this only those two questions, right?
Yes,
The
ma'am.
six-sided die mark this one and box contains. Okay, I'll check. Okay, we'll correct it and the marks will be given to you according to that.
Thank you, ma'am.
Okay, anything else? Otherwise, we can end the class.
No, ma'am.
Ma'am,
Okay,
from
then thank you.
11, week 11 and 12,
Hmm.
there will be questions related to those concepts in exam, right?
Yes, yes. Week
Okay,
11 and 12 will come in your end term exam.
okay. Thank you.
Okay, then thank you, everyone. We are ending the class
Thank you,
now.
ma'am.
Hello, ma'am.
Yes.
Ma'am, are you there?
Yes, yes.
Ma'am, I have a doubt in the extra activity 3.
Okay.
Ma'am, there was a problem with the, I mean, the review problem was there, no?
Yeah, only
So
two
someone,
options were visible, right?
yes, yes, ma'am. So someone have reviewed my activity, but that person have gave me 50 out of 100. But in the comment section, he have wrote that all the requirements of the activity are present, but due to the problem, he can't give the right options. So what should I do now?
Yeah, that was probably me.
Oh,
Because I did that to every, like, I did 10 peer reviews and I did this same thing to everything, like the correct option were not with me.
that might be.
Okay, okay. Okay, we'll see what can be done for this issue.
Now, one more thing, who checks these extra activities for final grading? Because I got 89 in my extra activity.
See, for discrepancies, we check from our end. So most of the time, what happens is some student gives you 100 marks, some gives you 20 marks. So for these kind of
Yeah.
discrepancies, we always check and you will be given the marks what you have done according to that. So
So,
don't worry
ma'am,
about that.
like,
But
my Excel sheet was perfect. Like, I did everything correct for activity 2.2, but sorry, the entire activity 2. But like, still I got 89. Why, ma'am? Like,
yeah, so if okay, it will be checked by us, and then whatever you have done according to that, we will give you marks.
no, like the marks is already given.
See, this is not the final marks. These are the peer review marks, or you are talking about the final marks?
No,
I'm
no, the
not.
final marks is like displayed in the current courses, like it's displayed in the dashboard.
So there will be something missing then in that case.
But nothing was missing. In fact, like some peer reviews gave me 100 also.
Okay, so all of them gave you 100 marks?
Not all, two gave 60, but those two gave a reason which is like invalid. Like they said that the charts were not present. But the first peer review which I got, someone gave 100 on 100 and he or she said that everything is correct and fine and all.
Okay, okay, we'll see.
Now, as far as I know, if there's an internet connection, then sometimes the chart takes time to load. So maybe those two fellows, they didn't wait enough, and that's why they gave me less marks.
Okay, but For that, we have formula. According to that, we calculated. Okay, we'll see if there is issue. For those options that I'll see if like two options were visible and they have done the peer review according to that.
And what about me?
Okay, I'll discuss it, but the final marks is already given, so
Like, isn't
you
there an
have to take
option to like, what should I say, re-appeal or something?
that. I don't know. I have not seen it, so I can't say.
Okay.